Hello everyone, my name is Isaac, and this is my Project 2 demonstration for software development for real-time embedded systems. So for this lab, we are running on an Arduino Uno, and we are using a TMP36 temperature sensor to be able to record temperatures over 5 minutes in a refrigerator and then 5 minutes at room temperature, outputting that data over serial and plotting it. So as far as hardware, we're running on an Arduino Uno, and we have our temperature sensor connected over to our analog pin A0. We are powering it with 3.3 volts, and it was important to me when I was doing this that I didn't want to lug my computer over to the refrigerator and have the USB connected the whole time, so I wanted to be able to run off of battery power. And so to do that, I needed to be able to take from the 5-volt pin to the reset pin on the Arduino, because when you connect the USB and initiate a serial connection, the Arduino automatically resets, but by adding this 100 ohm resistor between that 5-volt pin and the reset pin, you can stop it from doing that. That stops you from easily uploading your code, but hey, it's the trade-off we made here. So other than our temperature sensor, I've got a few LEDs hooked up that should indicate which kind of state and portion of our sensing we're in. And then because of the way that I'm doing this with the battery and a later connection to serial to get the data off, I have this push button that is connected to our digital pin 2, which is an external interrupt that we will use to tell the program that we are connected to the computer and that it's good to set up a serial connection and transmit. So as far as requirements go, these are what I've derived for the system. Go ahead and pause and read those as you like, and then we can do a brief demonstration. So I'm running a slightly modified version of the final code where I want to take measurement intervals of 5 seconds just for demonstration purposes, and then I'm only going to do 10 seconds at cold and then 20 seconds at room, and then we'll output those values. So when we plug in, the program immediately starts up. It will shine both LEDs to tell us that we are in our stabilizing kind of mode. So wait until we've got, right now it's 16 measurements, and that the average of those 16 measurements is less than 0.2 degrees off of what our most recent measurement is. As soon as that's done, it goes and tells you that you're in your cold by shining the blue LED, so it should be in the refrigerator at this point. So after 10 seconds, it jumps over into our move to room, so we're shining the red LED. And it should continue that. And now that we've finished both our cold and room temperature measurements, the LEDs will blink back and forth to tell you that it's now in idle, it's not collecting any more data, and it's ready for us to connect to serial and output our results. So now we can take and connect our USB. And then on our serial monitor, we can start monitoring. That opens the serial port connection. And then we push our button and we get our output. When that's done, the program goes into just a while loop that kind of kills it from there. So as far as what I'm outputting, I was seeing some weird stuff in my experimentation. In fact, it's still here a little bit, where the calibration data is a couple of degrees lower than whatever the measurement data is. I believe that comes from powering the temperature sensor and the LEDs. So because both of those LEDs are on during that stabilization period, I think you get a little bit different temperature readings. Either way, it works for the purpose of stabilization, in that those LEDs remain on the entire time, and so you're still looking for just a stable value. And then as soon as we go into our reading, again, those are comparable in that we have a single LED on during those periods. To try and combat this a little bit, I added this, I think it's a 10,000 picofarad ceramic capacitor to help smooth out any noise on the power line into that sensor. And I think that helped a little bit in some of my experiments, but for the most part, you can still see, right, we're getting about 2 degrees difference for just a regular run. As far as the complete 5 minutes in the refrigerator and then 5 minutes at room temperature, this is the data I initially collected. Looks pretty reasonable with what seems like an exponential drop off in temperature and then kind of an exponential rise. And so, yeah, that is my Project 2 demonstration. Thank you for watching.